Assalamu alaikum, dear students. Some chemistry numericals have more than one method to solve. Maybe they have a two methods, maybe they have a three or four methods. Same numericals today we will discuss related to the acid base titration. What is the volume of 0.1292 molar barium hydroxide is required to neutralize 50 ml of 0.1016 molar HCl. Barium hydroxide acts as a base and HCl is a strong acid. We will discuss its two methods to solve. First of all, we arrange its neutralization equation. Barium hydroxide, when react with 2 mole of HCl, barium chloride and water are produced. We know that the reaction between the acid and base, that is known as neutralization reaction, and as a result of neutralization reaction, salt and water mostly produce. Okay, in this balanced chemical equation, 1 mole of barium hydroxide react with the 2 mole of HCl. Okay, we solve it step by step. First of all, calculate the number of moles of HCl. We know that volume and molarity of HCl is given. How we can calculate the moles of HCl from the molarity and volume? Molarity and volume is given. First of all, 50 ml of volume change into liter and multiply with its molarity, and we find out 0.00508 mole of HCl. Okay, 0.00508 mole of HCl react with how many moles of barium hydroxides. So next step, to determine the moles of barium hydroxide needed to react with the 2 moles of HCl. So simple. We know that barium hydroxide and HCl used in 1:2 moles. So divide this number of moles of HCl with 2. The answer is 0.0025 moles. Okay, it's mean 0.0025 moles of barium hydroxide will be required to react with 0.00508 moles of HCl. Okay, next, by using this number of moles of barium hydroxide, we can calculate the volume of barium hydroxide by using the molarity formula. Molarity is equal to the moles divided by the volume of solution in liter, and by rearranging that formula of molarity, we need to determine the volume. So number of moles of barium hydroxide we have calculated, and molarity of barium hydroxide is given in the problem statement. By dividing the moles with the molarity, the volume of 0.01966 liter of barium hydroxide is calculated. When we change this liter into milliliters, the milliliter is 19.66 ml. The answer is that 19.66 ml of 0.1292 molar solution molar solution of barium hydroxide is required to neutralize 50 ml of 0.1016 molar HCl. Okay. Second solution of same problem, we use the formula NaVa is equal to NbVb. A stand for acid, B stand for base. Normality, N stand for normality, V stand for volume. Normality of HCl, NaVa in volume of HCl, Nb normality of barium hydroxide, and Vb is the volume of barium hydroxide. First of all, we determine the normality. We know that HCl is mono basic acid. It donates one proton, so its molarity and molality are same. So molarity is same and normality is also same. But barium hydroxide uh, provide two hydroxyl ion per molecule, so uh, its molarity and normality are different. For calculation of normality of barium hydroxide, we multiply the molarity with the 2 because it gives two hydroxyl ions. Okay, 0.02584 normal solution. That's the another word. That's the normality of barium hydroxide. Next, volume of acid is 50 ml. We change into liter, and we use this formula NaVa is equal to Nb and Vb. We will put all the values, and we can find out the Vb volume of the base. The answer is the same as we calculated in the solution number 1. There is no difference between the solution number 1 and solution number 2 with respect to volume. You can touch that solution which you can find easy for you. Okay, you can touch the solution number 1, or you can use the solution number 2 as you want. I hope so you got all the points related to this numerical. Thank you.